Okay, now, there are some pieces of this information that you may or may not know quite how I got to those numbers. This set of information here and this set of information there, by the way, I happen to know a little bit about calculus, and I will tell you, calculus is one of those things that makes finding those numbers quite easy. There are techniques that your graphing device will give you that help you find those same numbers. It depends on what device you're working from. Those of you with Desmos in your calculator, if you just type this in, you touch that dot, it should tell you that ordered pair, probably as a decimal instead of the exact value I gave you. But it should tell you that dot.
Is it okay for decimals?
It's fine. My understanding and my recognition is you are not calculus students yet. You're only pre-calculus students. Therefore, you don't know all the skills needed to do that particular set of information and find those exact values. We will be learning those in the future. I'll take my class in the future. It goes really well. Unfortunately, for some of you, you're going to graduate from us and move on and not take my class next year and not even have the opportunity. So I'm sorry, you're going to miss out. But for the rest of us, you have the opportunity. Please take advantage of it. But if you happen to have a Texas Instruments graphing calculator, one of your options under there is something known as a calculate menu, which is second of the trace key. Trace key next to the graph button. And if you look there, that's a calculate menu, and there's a series of options there, a couple of which, one is a minimum, one is a maximum. And so as we look at our graph that we have worked on here, you can notice that right here happens to be a relative maximum value because the curve kind of goes up and comes back down. Now, just for your information, so that we are aware, if something is a relative extrema, that means in the neighborhood that looks something like that, it is the largest value existing in that little neighborhood mathematically. Now, if something is a minimum, in the neighborhood around that particular value, it's the lowest Y value present in that neighborhood. That's what it means to be a relative minimum or a relative maximum. We also know that this is not the highest Y number the curve ever takes on. We can get higher Y numbers over here. And we also know that this is not the smallest Y number the curve has on. We can get lower numbers over here. That's why it's known as relative. That's why we call the word relative there. So that's extrema for us. That's what we're looking at. All right. For those of you that are working on one of those other calculators, once you select, let's find maximum. Once you select find the maximum, then it's going to come to the window and it's going to say, hey, we need to have a left bound, question mark, right? Is that correct? So you're going to move your left arrow key along the curve until your left arrow key ends up somewhere maybe right there. It's to the left, so you've gone up the hill and back down the hill. It's to the left of where that could be. And you hit enter at that point in time. Oh yeah, some of you might want to be writing down these instructions. I am not writing them down for you. So you as a student need to know that there are things that I say you need to write down, and I don't write them down. Also, once you've done that, once you selected that point and you select enter and it says now, what do you need? Right bound? Is that what it says?
Yeah.
Everybody staying with me? See. So now you move to the right and you're going to go back up the hill and come right back down the hill. So if you go up the hill and back down the hill, you're probably going to be on either side. And it's going to give you a little set of arrows, but it's going to mark that out and say, hey, here you go. We've got now a little set of boundaries. The key to this thing is that this highest point is within those boundaries. And now the calculator has a very limited amount of things it's going to look at. So then it's going to ask you one more question. It says, give me a guess. So I would go back up the hill slightly and say, I'm going to get as close to that as I can, put myself right there on what I think is the maximum number. Hit enter. It's going to think. It's going to kick out a number for you as a decimal and say, there you go.
So can you just go from here and then find it right there?
I would go back one more. I would make sure that those numbers are going back downhill. And I would come back this way to make sure I'm going back downhill. You got to have the up and downhill sides. All right? That's a practicing of finding that. Later, you should be able to try and find this minimum on your own. Just trust that I can do some math and that's the right answer. You think that's okay? Do check it later. Make sure you can have that happen. But that's the process you go through to find those extrema. So we have the relative extrema.
I don't know what extreme that
It is either this top point or this bottom point. That's where the curve turns.
is. Extreme.
That's what it is. Now, somewhat related to that, somewhat intertwined with that, is another idea, and that is the idea of increasing, decreasing, or constant values of the curve. And in order to work on that idea, I need to think about starting back in this direction at negative infinity for x numbers. And as I work my way along the x-axis and getting larger and larger x numbers, what kind of values are my y numbers becoming? Are they getting larger? Are they getting smaller as I go from negative infinity across towards something larger? So what's the y values doing? I mean, there's no answer to that question. What did you guys say?
Depends on whatever.
So for this specific curve, as I start coming this way, what are my y numbers doing? They're going up, right? So we would say that is increasing as y numbers. My question is, at what point in value for x does it stop having the y numbers increase? So you're telling me it's that x number. So if I am at the negative 2 square root of 3 over 3, in this region right here, my y numbers increase. But once I get to negative 2 root 3 over 3, what begins to happen to my y numbers?
Does it matter if it's parentheses or brackets?
Yes, it does. I want to use parentheses because right at that number of change, I don't know which is happening. So I'm going to leave it out of the parentheses. Where's the end of the decreasing? At what x number? And that's right there, correct? What happens right here? So then you have x as an element of the interval of 2 square root of 3 over 3 positive infinity, and it increases again. Does it do anything else across its figure? No. Okay. You kind of get an idea of how we write increasing or decreasing on this thing. Now the other thing I want you to notice is that the numbers which give me the boundaries for changing between increasing and decreasing happen to be those relative extrema numbers for x. So those pieces do tie together as properties in this problem. Any questions about this problem? Or any notations about yes?
So we can just write it INC.
Yes, you can do right that way. Any other questions?